Next, we will make a phone call from several feet away. Press the button to ring the number. You saw the LED flashed when the signal went out. We'll let it ring a few times. Stop the call. And now the strobe light has been triggered. It flashes for a little while at 6.2 volts, whereas the strobe voltage is 6.4. And then it stops. Pretty cool, isn't it? It is relatively difficult to detect mobile phone energies compared, say, to Tesla coil energies for two reasons. First, the mobile phone energies run at about 2 gigahertz versus 500 kilohertz per Tesla coil. And secondly, because they're much more weak. A Tesla coil might put out several watts and the mobile phone would put out much, much less than that. Now, however, I found a new way to detect them more sensitively. Most people use operational amplifiers to detect mobile phone energies. Here's one such circuit, which is quite typical and useful. We have an operational amplifier here that feeds into the base of a transistor and then a red LED to ground. The mobile phone energy is picked up by this antenna, and it will change the voltage very slightly across these two electrolytic capacitors to go input 2 of the operational amplifier. Input 3 remains constant as determined by this voltage divider and another really big electrolytic capacitor. So the difference in voltage temporarily between 2 and 3 coming from the antenna gives you an output which triggers this transistor and makes the LED light up to ground. Now that's fine, but it's not very sensitive because the energies are so weak we don't get much sensitivity. There's your operational amplifier, there's the transistor, there's the LED. New method is based on the fact that all single output operational amplifiers have a strobe light function built into them. Watch as I turn the voltage up slightly to 6.5 volts. This LED starts strobing. It all depends on putting a capacitor here, 22 picofarads, between outputs 1 and 8 to trigger the strobe. You just change the voltage very slightly. The strobe can go on or off, like 6.3 to 6.5. Now, if we use the strobe function, then the signal from our antenna doesn't have to be nearly as strong, just barely enough to trigger the strobe. The first thing you have to do is determine at what voltage the strobe light turns on in your particular circuit. So I'm going to turn the voltage up from our power supply just slightly. And you see it turns on at 6.4 volts. So now I'm going to turn it back down again, just a little below the strobe voltage, 6.3, 6.2, and it stopped strobing. Now the strobe is ready to go. We just need a tiny bit of energy into our antenna over here from the mobile phone to set it off and trigger the light again. Next, I'm going to make a phone call from several feet away. Press the button. You saw the light went on. Let it ring for a second. Stop the call. And now we've triggered the strobe light by the energy of the mobile phone over some distance from the phone itself. Next, we're going to send out a GIF file from my mobile phone across this distance and detect the energies of that circuit over there. Press the button. And as it's going out, you can see the strobe light's been triggered by the outgoing energy. And when it's received, it's also triggered by the incoming energy. We have the GIF on the phone. One final time, let's make another phone call. Put it a little bit closer. Press the button. Stop the call, and the capacitor starts draining off as energy from the call discharges through the LED.